Hey there, let's solve problem 938 of LeetCode in APL. And this problem is called range sum of BST. So the problem says, given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes. Return the sum of values of all nodes with a value in the inclusive range specified by low and high. So if we are given a binary search tree like this, and the low and the high are 7 and 15, then we need to sum the numbers 7, 10, and 15. Yeah, exactly. So, okay. Alright, so what I'm thinking about, or what I'm wondering, is how I should represent this binary search tree in APL. What would be a decent way of representing it? But instead of spending too much time thinking about it, let's just assume that we're going to represent it in a way similar to this, where the null is representing, I guess, the left child of the 15 here. So yeah, let's not waste too much time. Whoops, this was from a previous video, so let's clear those variables. So instead of wasting too much time thinking about how we're going to do that, let's represent missing children with the empty numerical vector. So that we get the ball rolling. So I'm not saying this is the best way to represent a binary search tree. I'm just saying we're going to do it like that for now. And this looks kind of silly, but at the same time, it makes it so that our problem is easier to tackle, because we can, first of all, we can easily... Wait, can we? Can we do something like this? Yeah, exactly, we can't. So we want to find... we want to find the missing children so that we can remove them from the input. So now the missing children are gone, and now what we can do is we can use the low and the high values. So low and high are 7 and 15. So this was that. So low and high are 7 and 15, and I like to have the parentheses here. And now what we can do is, well, let's take the children that matter for this particular case, and we will interesting. So we will take the low and we will check which values are greater than or equal, and the values that are smaller than or equal to the high. So this produces a mask again, and now we need to filter it once more. But actually, let me check what happens if I don't filter the input at all. But now can I use this? So it's not erroring there, but I'm not getting a 1, which I really wanted. Yeah, so it's probably best if we do filter first for the empty vectors. And after we filtered it once more, what we can do is we can compress it. So we're going to compress the values that we got. They go in here, and then we compress them according to the Boolean mask that is built here. But now the issue is that this can be seen as an operator, so this is binding with that. So we need to do something about it, and this is one convenient way to stop the compress, stop it from behaving like a reduction. Alright, so we don't really need to do this because we want to sum them, so we don't need to extract them. What we can do is we can multiply, so this is simpler, and then we sum everything. Now I wonder, if I don't filter, I think, yeah, we can't really sum. The sum doesn't work, so we do need to filter. at least for now. All right, so yeah, okay, this is one possible way to tackle this problem. If you have alternative solutions, what you can do is, well, you can go to the comments, or they're probably going to get deleted by YouTube. It's not my doing. YouTube just deletes them automatically. So what you can do is you can add them to the GitHub repository that is going to be linked in the description. I'll see you soon. Bye. Right, sorry. PS. Just as a side note, I was thinking, and it's silly to be doing this sort of filtering. We can simply, so I had some other input here. What we can do is we can just enlist everything and get rid of the empty vector. And this is we can just do this. We can enlist. We don't need to filter in this particular case. So yeah, for this input, the result should be 23. But instead of filtering, which is just a lot of work, we can just enlist everything. Or if you don't like using enlist, you can concatenate reduce. So you can join things. I'll show you what this looks like. It's just the input without the empty vectors. Yeah. Bye.